Kerbal Klassroom! Welcome to class. Today we're learning about mods to calculate thrust weight ratio and delta V. Alright guys, it's time to start using a mod. So let's first download this nifty tool which helps us to download and install mods easier. Mods are basically copy paste. This helps us to get updates easier and select mods from a nice sorted list, and it's a great tool. Anyway, it's called ccan.exe. If you look on Bing and look for ccan.exe, it's the first link. Then come down here to the download section, click on the exe, wait a few seconds, and then when it's done, you can copy paste this to your desktop, or you can just run it from here. Technically, it doesn't really matter a whole lot. We're going to, let's see, would you like to refresh ccan's mod list every time it's loaded? Yes. We're going to look for Kerbal Engineer Redux. This is the mod that we want. Apply changes. Down at the bottom right, also hit apply. And you can launch KSB from here. I'm just going to close this though, since we don't need it anymore, and launch it from down here. Now it's going to ask us, do we want to check for updates for Kerbal Engineer? That's something built into Kerbal Space Program now to check for updates on mods. You can go ahead and click yes. Now when we start our game and go to the vehicle assembly building, you'll see this nifty tool which I was talking about last time. Let's go ahead and open up our payload ship from last time. And now we see this nifty tool. Let's go ahead and click the compact view for now. Oops. Did not want to grab that. Control Z undoes things. So this tells us that originally we have 1.96 thrust weight ratio, and when it's run completely out of fuel except for that last drop, it will have 10.82 max thrust. Let's go ahead and pull this away and add a tiny, actually we can just grab the thing here just like last time. Grab this guy, and it says it has a max, or a thrust weight ratio of 1.8 and a max of 8.18 or 6.18. And if we put a decoupler on here and combine the two, fix the staging. Now it shows two stages. The first stage that will fire is the highest number because we're going to count down through the stages as we click them. So we will start with 1.93 in the on the launch pad, and we'll eventually get up to 10.09. And then when we fire this engine, as we decouple, I can go ahead and combine these. Now it's stage 1 and stage 0. This will have 1.8 thrust weight ratio, which if we take this off, it still does. So the major difference is we've increased the total amount of this thing called delta V. Now I don't want to go into a whole lot of detail right now because I'm going to be going into more detail later, but delta V is a change in the meters per second that you're currently going. Delta is a Greek symbol and it means change, and V is for velocity, so the change of velocity. So if we started off the pad going 0 meters per second, if there was no gravity and no aerodynamics to worry about, that means that these two orange tanks in this mainsail could get this entire thing going up to 5,000 meters per second. And actually I think if we click this and tell it we have no atmosphere, that's a little bit more accurate. So if we would be going 5 kilometers per second at the end of this orange tube burning. And then if we started this engine and kept it going, we would get up to 8.889 kilometers per second. So we'll get into how you calculate that, but right now let's just let this tool do the calculations for us and figure out how we can design better rockets with this information. So let's do another stage like we did last time. Actually, I want that to stay on there. Let's put a, where is that part? It's in structural. This little guy, let's put a not a tall swivel, I wanted a full swivel. Full swivel, and then under that, let's put a decoupler. And back in structural, we'll add the next largest. There it is. Okay, so this gives us a little bit better aerodynamics. Let's zoom back out a little. Now we have a much taller craft, which has a small disadvantage of, wobbling a bit, but let's ignore that for now. Let's fix the when the engines fire. Okay, now we have 3 stages. If we fired this engine from the launch pad with no gravity to worry about and no aerodynamics, we would go from 0 up to 3,787 meters per second in this first stage. Now, if you remember a few minutes ago, it was about 5 kilometers per second, so we've actually lost 1.3 kilometers per second in our total speed. That's because we added more mass to the upper stage. And if you remember last time, the more mass you have, it reduces your total thrust to weight ratio, but it also reduces how much speed you can pick up, because force is mass times acceleration. Well, if you increase the mass, that means the total force that you have is greater for the same acceleration, or if you put out the same force, that means you have less acceleration. Okay, so this next stage, we'll put it up to 7.4 kilometers per second, and then this next stage will bring it all the way up to 11.2 kilometers per second. Now, the first bit that we're going up, we are fighting gravity, and so we're not actually going to make it a full 3.7 kilometers, and we're also fighting aerodynamic drag, so this is more likely to be something a bit lower, and this tool can help you to simulate, well, what would we lose just from aerodynamic drag, and that's dropped another 300 meters per second or so off of the estimate here. You can also assume that you're going to lose a bit from gravity pulling you back down, and so a nice good estimate for getting into orbit is about 4.5 kilometers per second of delta V. So that means that once we get up into the upper atmosphere, we're going to be dropping this first stage, or rather our stage 2, and then we'll get down to stage 1, and then stage 0. We'll burn up a bit of stage 1 in the upper atmosphere to circularize our orbit, but we'll have enough that we could use this whole bottom stage to launch us out to one of the outer planets, and maybe even do a capture with this one. Now, there's a nifty subway map. Let's go ahead and look at my desktop background. There's a subway map of the Kerbal system that suggests how much delta V you need to get to various places. So if we're starting here at the bottom, you need at least 3,400 delta V to get in a circular orbit at 80 kilometers. I always pad that a little bit to account for the fact that I'm not necessarily the best pilot, and also aerodynamics and things like that of my ship design. So I estimate, you know, about 4,000, 4,500 delta V to get in a nice circular orbit. And then once you've gotten that far, if you want to bring your orbit up to 2.8 million meters, that would bring you into what's called a geostationary orbit, and that requires 1,115 delta V to bring your orbit up to that. So you add these two, 3,400 plus 1,115, and that tells you you need about 4,515 at minimum to get into a geostationary orbit. If you wanted to go to the moon, to MUN specifically, you need about 860 delta V to get a flyby. That makes it so that you bring your apoaps up to the same orbit as MUN, and as you pass by it, you will return back to Kerbin. If you burn another 310 delta V, then you can get down to a 14-kilometer high circular orbit, and then if you burn another 580 delta V, you can land safely. So you can kind of plan your visits to different planets. Minmus is a lot farther away from Kerbin, but it doesn't require a whole lot more delta V. In fact, it actually requires less delta V to get to, because Minmus is so tiny that to get up to it requires an extra 70 delta V, but then to be captured in the orbit of Minmus at 10 kilometers high circular orbit only requires 160 delta V, and then landing is 180. So total delta V to get to Minmus is even smaller than MUN. And so when you're planning your trips, if you build your ship so that you look at this number that's produced, delta V, and you look at the subway map, you can get a good idea whether or not you can get there safely. Now, especially for new players, you're going to want to pad the amount of delta V that you have, because you're going to not do the precise of maneuvers as you want. And so give yourself an extra 20% delta V to get to each place, and that will make it so that, you know, you have a little bit of fudge factor in, you know, accidentally burning the wrong direction, or needing to do some more course corrections in the middle of it. So this ship would be able to get to Moon, and probably out to Minmus as well, and then back to Kerbin. Although I don't have any science parts on it. I also don't have any antennas or any heat shields or parachutes. So as soon as we start adding things like here's a thermometer, and here is a accelerometer, and here is a pressure meter, and here is a little antenna. Let's go ahead and move this out of the way. And here is a tiny parachute that won't work because there. So we've reduced this down to less than 9 kilometers per second of delta V, because we weighed down this upper stage even more. The lower stage, I think, was at like 3.7 kilometers per second in our estimate, or maybe that was, I think it was close to 3.7. Adding these different parts, no, the 3.7 was definitely with it being in space, not adding these parts. So we didn't really reduce the total delta V of this bottom stage a whole lot, because relative weight, adding a few little things up here doesn't matter. But we did reduce the just adding this parachute drops from 3150 down to 2705. That's 445 delta V that we lost just from adding this parachute, which weighs, a little hard to see, weighs 0.1 ton. So as you're designing to get to different places, getting off the pad is important. So this lower stage down here, 1.5 thrust to weight ratio, and getting to places you need to have enough fuel to burn so that you can change your velocity the right enough amount at various places, and then you can get around Kerbal system. So another thing that I wanted to show you guys while we're here is if you want to have let's get a coupler. Let's put this larger coupler because then it's easier to see. I think I rotated that the wrong direction. There we go. Okay, if we wanted to add some fuel tanks on the side here, and let's make them like this, and if we use this particular part, it's called an external fuel duct. We can transfer fuel from this outer section to this inner section, and then when this tube runs out, we can have this decoupler launch it off the side, and we lose a bunch of weight. These tin cans that are empty, we can lose that weight, and now we can have this this center section still full, because it's basically using this stuff first and then using this stuff. So if we, as long as we get the staging correctly, like that, now you can see that this first stage, which now has a 1.7 thrust to weight ratio, so it's actually a little bit too low. Let's go ahead and add some reliance. They are high thrust, lower weight than the swivel, and so we make sure that those guys fire at the same time as this. Now we've increased our thrust to weight ratio of this first stage. The first stage is now this side stage though, and it will get up to 851 meters per second of delta V. We drop that guy off, and this whole center section is full. Now the disadvantage here is there's more things on the outside that cause drag, and if you drop the outer stage off and it falls inward and hits the engine down here, it could cause that to explode. There's ways of dealing with that, like adding these little separatrons. Put one on that side and on this side, and when you where's this guy? Okay, so I've added these separatrons to fire. They're basically little tiny solid rocket boosters. They have very little mass. They have 13.7 kilonewtons of thrust with 8 units of solid fuel. I think they burn for about 3 seconds, and so they're basically little buckets of propellant. If you have those guys go off at the same time that you hit your decoupler, then it will pull this away from the stage. As long as you get the separatrons kind of centered for where the mass is here, then it will pull it away well. You can also put some down at the bottom and some at the top, and that will also help it get to the right place. Want to do that. And then the other thing to know is that you can use these structural connectors to reinforce things. Let's go ahead and add like 4 if we wanted to, like this. That would add a little bit more structural support. It does add, I think, a little bit of drag, but it helps prevent wobble of this upper stage, and it does add a little bit of weight, so it does affect the delta V. These are 0.05 tons each, and I don't think that the length changes the weight, but maybe it does. I haven't actually figured that out. Let's just do an experiment. Okay, so if I say to here, the weight is 90.170, and if I say all the way to here, it's the same. Yeah, so the length of the struts doesn't matter terribly, but it does affect, you know, how much this thing flexes around. Now these struts are kind of like magic in real life. there isn't some crazy magical part that you can extend up like this that has no flexibility to it at all. So, you know, this helps the game be a little more playable, but I don't think that there's really a whole lot of things in real life that that you can do such magic with. Anyway, that is some more to help you guys understand how to design your rockets so that you can get around the solar system, Kerbal system. Yeah, I hope you guys have an easy time downloading the ccan.exe and getting Kerbal Engineer. Let me know if you guys have any problems with that. We will be downloading other mods with CCAN later, but for now this is the only mod I want you guys to download. It really helps the game immensely. When you're playing in the vehicle assembly, you'll see that. You'll also see this flight engineer thing. You can grab it and pull it over here if you want to have little buttons that tell you for each of your stages, you know, this is your total delta V left, this is how much is left in your current stage, your next stage, your next stage. My current thrust to weight ratio is 0 because there's no fire coming out of the bottom of my engine, but if I turned it on all the way, it would, you know, this is the maximum currently because of the weight of my ship. That's the most useful things there. If we want to look at our orbit, right now we don't really have an orbit, so it's kind of hard to show this off. Let's actually, while I'm doing this episode, just kind of show this particular view. This is the vessel view, and up here at the top you have some extra things that are really quite useful to have even if you don't have this showing. This is your apoapse height, your periapse height, your time to those places, your current altitude, vertical and horizontal speed. Horizontal speed is extremely useful to know when you're trying to land on a planet, because you could be coming down at 1 meter per second, but you might be going to the side like 15 meters per second, and that means that as soon as you touch down, your top is going to fall because the bottom will hit friction. And anyway, let's go ahead and launch real quick, and I just want to show you the delta V of this second stage is dropping. The first stage is also, or the total is also dropping, but the first stage and the second stage, they are only changing because it is saying, oh look, the atmosphere thickness is different, and therefore I think you actually have more delta V now because you're not going to be going through the atmosphere. So that's why those ones are going up and this one's going down, is because it's kind of changing between lower atmosphere estimates and as you get higher in the atmosphere, the estimates. And let's go ahead and time warp just a little bit. Hopefully it doesn't wobble and fall over. And I'm going to turn and you can see my apoapse is already at 106 kilometers now. You didn't have to switch to the map view, which we can still do. This now says 106, this says 106. So to me this is so useful to get into orbit, so I don't have to switch back and forth between the two views just to see these two numbers. You can also see your inclination, which is how tilted your orbit is, how eccentric it is. In this view, you can also add things up here by clicking over here and editing HUD1. You can add, let's add the there it is, the very top one. Let's add the inclination up here. Now the inclination is included, and I don't have to have this orbit thing up. And if we wanted to switch, if we wanted to add how much delta V is in the current stage here, so that we don't have to keep these clicked on. There's all sorts of wonderful things that you can get with Flight Engineer in your HUD, so that you can not have to click on so many things. Monitoring this little progress bar of how much liquid fuel is left is sometimes not accurate enough for me, and so seeing, I usually have this one open, how much is left in my current stage. Since I know I'm going 400 meters per second, I'm near my apoaps, and I have 1,600 left in my current stage, I might be able to get into a nice clean orbit, but I'm probably going to detach this lower stage and burn just a little bit more to actually circularize. And I'm going to also time warp a little bit by pressing Alt and period. And it's telling me, yeah, you're going to have some physics warp stuff going on if you do this, which I'm well aware of. And there we go, we ran out of fuel. We do not have a circular orbit. We still would fly into the planet. I'm going to press space to detach my lower stage and start my next stage. My next stage currently has 3,400 delta V, and now I can see that my periapsis is at 99, my apo is at 121. I am in a nice, fairly circular orbit above Kerbin, and as we go to the map, you can see that. In the next episode, I think I'll probably be teaching you guys how to get out to a geosynchronous or geosynchronous orbit, and how to do a flyby of Mun and a flyby of Minmus. Let me know in the comments if you have any questions about Delta V. We will probably, in a later episode, go over the math of how to calculate that. It is on the cheat sheet that I showed you last time on the Kerbal Wiki. And until then, thanks for watching, and your homework assignment today is to go and get ckand.exe, install Kerbal Engineer, and try building some interesting rockets. Maybe make a video of your rocket and send me a link in the comments, and have a lot of fun.